Welcome to lesson 5.2, an introduction to ratios. So last one was rates. This lesson is about ratios, and a ratio is a comparison of like quantities. So one of the key features of a ratio is because they are like qualities, they will have matching units. And if we were to write something like 10 kilograms over 2 kilograms, the units can cancel out, so we don't write a ratio. Don't write with units. Units are for rates, not for ratios. So we can write them using the colon. So A to B, we would pronounce that A to, like A to B. We're going to use the colon. And one method often used to solve such problems is to use a scaling factor. And we're going to be using the letter K for that. And I'll do a couple of examples in the lesson. When we equate two ratios, this is a proportion. So here's some more terminology that we're going to need. So a proportion would look like, I don't know why. Nope. Okay, I'll go around the other way. There. So a proportion would look like that. And if that's our proportion, it's got the equal sign in the middle and a ratio on each side. So cross multiplying, which we're going to use, it can only be done, and we did it in the last unit, it can only be done across an equal sign. So that is like super duper important. Cross multiplying is not the same as canceling. Canceling we do when there is no equal sign on the side of the equation that we're canceling. Cross multiplying is done across the equal sign. So for here, they want us to solve for x. I'm going to do yellow first. So 18 times x is 18x. 3 times 24 is going to be 72. So 18x equals 72. Divide both sides by 18. And I get that x equals 4. And this method of doing it will always work. So even if we've got decimals, we're going to do cross multiply. So I would get 4.9x equals 3.36 times 1.75. And on the calculator, I get that to be 5.88. So 4.9x equals 5.88. To get x by itself, it's being multiplied by 4.9. So I'm going to divide both sides by 4.9. And we end up with x equals 1.2. Scaling factors, I mentioned them before. So we're going to use a scaling factor, and I'm going to go straight to an example. Okay, so take the molecule for water as an example, H2O. It's telling us that the ratio for of hydrogen to oxygen molecules, atoms, atoms, is 2 to 1. So if we have a total of 30 atoms, an easy way for us to figure out how many of them would be hydrogen, we can write them instead of just 2 to 1. I'm going to show you something. So if 2 over 1 would be equal to 2k over 1k, right? Absolutely equal because it simplifies to the same. The really neat thing with the scaling factor is, say, if this is the total amount of all my hydrogen, and then this is the total amount of all my oxygen, I know that hydrogen plus oxygen, I'm now over here on the side, hydrogen plus oxygen has to equal up to 30 atoms. So I'm not solving for the number of hydrogen or oxygen right now. All I'm going to solve for here is K. That's my scaling factor. But once I know what K is, I can go back here and say that I'm going to have 2 times 10. Oh, let me change colors. 2 times 10, scaling factor, use it here. 2 times 10 equals 20, so I'm going to have 20 hydrogen. And then 1 times 10, but that's an easy one, means I'm going to have 10 oxygen. And that is how we work in that question. Here's another one that starts from a different point of view. So new point of view, but still H2O. If I tell you that we have 12 hydrogen atoms and I ask you how many oxygen atoms there must be, since 2K represented the hydrogen, and I think I was using green, since 2K represented the hydrogen, I can write 2K equals 12, right? Because 12 hydrogen. Solve for K equals 6. And since oxygen is just, oxygen was just 1K, that would be 1 times 6, which just equals 6 oxygen atoms. And overall, we would have a total of the 6 oxygen plus the 12 hydrogen, which gives a total of 18 atoms. So let's practice that. J has 80 cents and M has $1.20. They put their money together, buy a $2 box of almond chocolates. If the box contains 25 chocolate-covered almonds, how many almonds should each of the children get if this is in a fair ratio based on how much they put in? So we're going to let K be the scaling factor. Let K be the scaling factor. And if we do this, we know that J's part is going to be 0.8 K. Well, let's back it up a step. The ratio of J to M would be 0.8 to 1.2. But I could just as easily write this as 0.8 K to 1.2 K. And we know that the total that we're trying to figure out how much each gets of these chocolate-covered almonds, we know that the total is going to end up being 25. And the 25 comes from J. J had 0.8 K, and M had 1.2 K. And when we solve for K, then we're going to be able to find out how much each person had. So I get 2K equals 25. Divide both sides by 2. And we get K equals 12.5. But I want to go back and solve now. I'm going to use this. And I know that J got 0.8 K. So it's going to be 0.8 times 12, 0.5. 0.8 times 12.5 equals 10. And then 1.2 times 12.5 equals 15. So that means that J gets 10 almonds and M gets 15 almonds. And you can always check and see if it makes sense. And 10 plus 15 is 25. So that's a really good indication that we've done it correctly. Question 3, we have J, S, and W. They all contributed respectively 10 grand, 20 grand, and 30 grand to open a new business. At the end of the year, the business made a profit of $240,000. How should the 3 people split the profit? This is, again, presuming that they split it based on how much money went in. So we know that J to S to W is 10,000 to 20,000 to 30,000, and I could write that as 10K to 20K to 30K. I know that my grand total is 240,000. So I can add up all these parts. So 10K plus 20K plus 30K equals 240K, 40,000, sorry. So 60K equals 240. So when we divide both sides by 60, we get that K equals 40. And when we use this now to get our actual amounts of dollars, this one was going to be 10K, and then we'll add our 3 zeros at the end. So 10 times 40 10 times 40 is going to be $400,000. That's how much J gets. S gets 20K, or 20 times 40. So that's going to be 800. Oh, I must have one too many zeros. I do. And I knew that because my amounts wouldn't have added up to the grand total of 240. Okay, W is 30K. So 30 times 40. So that's going to be $120,000. And we can check and make sure we're right. So if we add these all up, 120,000 plus 80,000 is 200,000 plus 40 gives me $240,000. So, yep, we did that question correctly. Last year, question 4. Last year, 180,000 people immigrated to Canada. They came from Europe, the rest of America, Asia, which also includes Oceania and Australia, and Africa, in the ratio of. So these numbers here, they're going to be lining up with the words in the order they showed up. So that 4 is going to go along with the first word. So Europe is going to be 4. And then 1 is going to be the rest of America. And then 8 is going to be for Asia plus Oceania, Australia. And then 2 is going to be from Africa. And we know our grand total is 180,000. So we're going to do that scaling thing again, right? Because I can write 4 as 4K, 1 as 1K, 8 as 8K, 2 is 2K, and it's all still will reduce to the same ratio. And I know that 4K plus 1K, that's a terrible K, 1K plus 8K plus 2K equals my grand total up there of $180,000. So let's figure out what each K is. So 2 plus 8 is 10 plus 1 plus 4. So 15K equals 180,000. Divide both sides by 15. And we get that K equals 12,000. And if we use this, K equals 12,000, and we use it on this line here, that means Europe, which is 4 times 12,000, is going to be 48,000 people. All of these are going to be in people, right? America is just 1 times K, so that's easy, 12,000 people. Asia is going to be 8 times 12,000, which is going to be 96,000 people. And then Africa is 2 times 12,000, which is 24,000 people. And we can add them all together, and when we do that, it very nicely works out to be 180,000. Question 5. Bronze is an ally that contains the metals copper and tin in a ratio of 23:2 by mass. And then it wants us to find the mass of each metal present in a total amount. So here's our total amount. So we know that copper to tin is 23:2, which I can write as 23K to 2K, and I know that when I add those together, I'm going to get my total, because it's the stuff from my copper plus my tin equals 175. So 25K equals 175. Divide both sides by 25 gives us 7. So that's what our scaling factor is. It's going to be 7. And then I'm going to use that. I'll write it out again. Copper, tin was 23K and 2K. So copper is going to be 23 times 7. And 23 times 7 is 161, that's going to be in grams. And then tin is going to be 2 times 7, which is 14 grams. The next one asks us to work out how many grams of copper are there for 68 grams of tin. So if this time we're looking more like a ratio, so copper to tin normally is 23 to 2. They ask us how many grams of copper, so that's our unknown X, and tin, they told us, was 68. And we're back into a cross-multiplying situation where we get 2X equals 23 times 68, which happens to be 1564. We want X by itself, so divide both sides by 2. And our answer is 782 grams of copper. Question 6. The dimensions of a rectangle are in a ratio 8 to 3. If the longer side is 30 centimeters, what is the length of the shorter side? So if we were going to draw a rectangle, we know it's in the ratio of 8 something to 3 something, right? We just know it's in a simplified ratio of 8 to 3. So if we look at long to short, actually, let's just write, I'm going to write that as length and width. No, I'm going to write it as long and short. Third time's a charm. Long and short. Long to short is 8 to 3. They told us the longer side is 30 centimeters, and they want us to find the shorter side. So this is just a straight cross multiply. The pink gives me 8x. The blue gives me 3 times 30, which is 90. So we get 8x equals 90. We want x by itself. Divide both sides by 8. And we get that the shorter side is 11.25 centimeters. And like I mentioned before, there are other ways of doing it. That's just the way I chose. The next one says 2 squares have a total area of 160,000. Knowing that the sides of the 2 squares are in a ratio of 3 to 7, find the area of each square. So this is where we're going to get something a little bit new. So if I have a small, it'll draw nice squares for me, so I should let it. A small square, and then I have a bigger square. If I know that their ratios of the sides is 3 to 7, let's just take a moment to think about what that means for the ratio of the areas. So if the ratio of the sides is 3 to 7, so if we're looking at the ratio of the sides is going to be 3 to 7. Then the area of this one would be 9, right? The small square is going to be 9. The large square is going to be 49 because area always takes your sides and then squares them. So that means the ratio of the squares or the areas would be 49. And we did all this because they have told us what the total area is. They didn't say the total length, total area. So that means we know that the ratio we're going to be using is the 9 to 49. I'm going to use my scaling factor because I have a total. So 9k plus 49k equals 1160. Combine like terms, I get 58k equals 1160. Divide both sides by 58. And that's a bad O. It looks like a 6. And I get that k equals 20. But that's just our scaling factor. So that doesn't really help. So we have the small square and the large square. And now we want to find the area of each square. So small versus large. Small was 9k. Large was 49k. So taking my value for k and substituting it in. For 9K, it's going to be 9 times 20, which is 180 units are centimeters squared. And the large one, we're going to have 49 times 20, and that equals 980 centimeters squared. So we just found that the area of each square, the small one is 180 centimeters squared, and the large one is 980 centimeters squared. Question 8. To make orange juice from frozen concentrate, you use concentrated water in the ratio, so concentrate and water in the ratio of 1 to 3. How much concentrate and how much water do you need to make 1 liter of orange juice? But then they want us to give our answer in milliliters. So this is our total. And when we have parts and a ratio and a total, that means we're going to use that scaling factor. But the fact that it's milliliters over here means I'm going to write my total as 1,000 milliliters. So the ratio is 1 to 3. So in terms of scaling factor, it's going to be, I could write it as 1K to 3K, which means that it's 1K plus 3K equals my total of 1,000. So 4K equals 1,000. Get K by itself. Divide both sides by 4. And we get that K equals 250 milliliters. Sorry, K is just 250. But then I'm going to use that because my concentrated was 1K. My water was 3K. So that's going to be just 250 milliliters of concentrate. And then 3 times 250, which is 750 milliliters of water. Last question. To make 16 super delicious cookies, one needs 500 mils of flour, 200 mils of baking powder, some salt, some milk, and olive oil. Looking at this, there is no sugar, so to me these are not cookies. They would make, I don't know, maybe like some sort of scone. But you could put like Nutella. You guys would, I wouldn't. Or jam or peanut butter or just nice butter if it makes scones. So I'm going to change these to scones. How much of the ingredients are needed to make 48 of them and then to make 20 of them? So we've got flour to baking powder to salt to milk to olive oil is 500 to 20 to 4 to 120 and then again 120. This makes 16. So to make 16, that would be what we need. But now we want to make 48. So if we want to make 48, the first thing I'm going to do is to see how many times 16 divides into 48. And what would you have to multiply 16 by to get 48? And the answer 3 is that I'd have to multiply it by 3. So then the ingredients to make 48 scones, I'd have to take every single part and multiply it by 3. And when we do that, we get, so really that 3, that's going to be our scaling factor. It's like saying that K equaled 3 because we're multiplying every single part by that. And when we do that, we know we're going to get 1,500 milliliters of flour, and then we need 60 milliliters of baking powder, 12 of salt, 360 of the milk, and 360 of the olive oil. The next one wants us to make 20 cookies. So scones. If we're doing 20, our scaling factor this time, how many times does 16 divide into 20? So our scaling factor here, our K here, would equal 20 divided by 16, which is 1.25. So for here, I'd have to multiply my original times 1.25, my original times 1.25, original times 1.25. You get the picture. And when we do the calculation, we find out that that would leave us with 600, not 600, 625 milliliters of flour, 20 times 1.25 gives me 25 milliliters of baking powder. 4, because remember it's up here, times 1.25 is 5 mils of salt. 120 would give me 150 mils of milk and the same of olive oil. So we've answered that question. And the next one, it says, Alex has 2,000 mils of flour, 100 of baking powder, 50 of salt, 40 milk, and 500 of olive oil. What is the largest number of scones that he can make? Well, one of these is going to be a limiting factor, right? So it's going to be that we don't have quite enough of something. And I'm going to show you the way that I would do it. We're going to see what the scaling factor would be for each ingredient to get to the original. So for flour, we have 2,000 mils. The recipe calls for 500. And when we get the scaling factor for flour, so K for flour would be 4. It goes in 4 times. So if we were looking at the flour, it looks like we can make 4 batches. Then we look at the baking powder. We have 100. The original asked for 20. So the scaling factor, or K, for the baking powder is actually 5. So we have enough baking powder to make 5 batches. For the salt, we have 50 mils. It only needs 4. So our scaling factor for the salt is 12.5. We got more than enough salt. So right now, looking at these, it looks like the limiting factor would be the flour, because we can only make 4. We only have enough flour to make 4 batches. But we'll check it out for milk and olive oil. So for milk, I can just write M because it's the only M. For milk, we have 400. It asked us to have 120. And when we divide that, we get that the scaling factor for the milk is going to be 3.333. So 3.3 repeating. And then for olive oil, we have 500 mils. And each batch needs 120. So when we divide that, we get that K is 4.666, so 4.6 repeating. So when we look at all of these, the lowest scaling factor is for the milk right here. And that means we only have enough milk to make 3.3 batches. So I'm going to just write out the limiting ingredient would be milk. Would be milk. So the most we could make using this recipe, we could make with this recipe is going to be with a scaling factor of 3.3. So we can make 3.33 batches. Our original batch made 16. So to be 16 times 3.3 repeating, that would be 52.8. And if you're talking about baking, you can always make one a little bit smaller. So really that would be 53 of the scones. And that's it for lesson 5.2. Thanks for watching.